RIS diverts the signals towards the buildings. So we can add IRS to my LED infrastructure. Okay. So, so it is a very good paper. So now look at what the changes we have brought to OFDM of a wireless communication system to make it to make the system to make the system and to pass this signal through our LED. So first one, if you look at, we have taken an input. So this input can be a PAM, QAM, or MPSK, any signal. And we all know that when we are using a orthogonal frequency division multiplex format, this is for high data rate communication, and so we stack all the bits into which are coming from serial to parallel format, and we give this signal to directly to IFFT. But whereas if you are going for a visible light communication, we use a Hermitian symmetry block. Then we add cyclic, after IFFT, we add a cyclic prefix. Then we'll convert that cyclic prefix to signal to a bipolar to unipolar, what I said, because this bipolar to unipolar are different, like my signal has a bipolar waveform, then I have to add some bias to this so that it will be shifted totally to the positive value. Then again, serially, we are transmitting over the optical channel. Again, the same reverse process will adopt in the receiver section. Okay, so if you look at my Hermitian symmetry format, what we are going to do, so the sequence of bits are comes into my channel like 10111000. So first we'll take 10, so one symbol. Next symbol is 11. Next symbol is 11. 00 is another symbol, and so on and so forth. So this 10 is mapped to A plus J beta, right? So this A plus J beta is directly given to IFFT. So, but before giving to the IFFT, we add a Hermitian symmetry, right? So we'll explain what is this. I'll explain what is this Hermitian symmetry. Earlier, I stored this information. So, like if a OFDM is working n point OFDM, so that means n point IFFT block we utilize. So this n is given for orthonormal basis functions, right? So each signal is passing through one orthonormal, similar to your one orthonormal basis function. So now from 0 to, if I'm using 0 to n minus 1 point, that means n point IFFT, we take the middle point, that is n by 2, as 0, and the first point also we make it, that means irrespective of my signal, I don't transmit any signal from point 1, point 0, right? So first and the middle are made as 0. Then 1, 2, 3, 4. So where I'll put my data 1, 2, 3, 4, and so on, so forth up till x of n by 2 minus 1 will put the data. Then the middle is again 0, right? So middle is again 0. After the middle, we just take the complex conjugates of from x1 to x of n by 2 minus 1, and we'll fill those complex conjugates in the reverse order. Like after middle, we'll fill with x conjugate of n by 2 minus 1, and so on, so forth, x conjugate of 4, 3, 2, 1, and so on, so forth, like this. So this is the inverse fast Fourier transform IFFT. But because of this Hermitian symmetry component, the output of your IFFT will become a real valued signal. So earlier I have written one expansion here. So here you look at x of n is 1 by n, k equal to 0 to n minus 1, x of k e power j 2 pi kn by capital N, right? Because this is an IFFT block. So for IFFT block, input is x of k. Okay. So k, here n is n number of carriers. Now we are taking from IFFT block x of small n. So this small n, we kept first value as x of k as 0, and middle value is also 0. Middle value is 0. Rest all complex conjugates. So if you add all of them, look at this explanation. So first bit, first place in the first carrier 0 and the middle carrier is 0. And x of n minus k we are taking as x conjugate of k's. And in such format, if you are arranging your IFFT block x1 to x of n minus 1, the rest portion is conjugates, complex conjugates. Then if you write the expression for x of n, this is my x of n. And if you open the equations of your outputs, this is 0. And only k equal to 1 to n by 2 minus 1 only I have a data, x of k data. And middle portion is again 0. And k equal to n by 2 plus 1 to n minus 1. We have used a complex conjugate values, right? This xk is a complex conjugate value. So that again will keep inside this expression. So this one is remaining and this one is remaining. So right. So this one is remaining. So after adding these two, k equal to n by 2 minus 1 only remaining. So this is not remaining. So this is brought here, and the next one is this one is remaining. Now we will use x of n minus k as x conjugate of k. So if you use that conjugate of k as in using the translation with the variables, finally what we obtained by solving this equation is a Hermitian symmetry. There is no complex conjugate. See, cos format and a sine format, right? So cos and sine format, as we know, it is a real valued signal obtained by Hermitian symmetry. So this is where the concept of visible light communication lies. And this Hermitian symmetry format is given to your IFFT block. Then IFFT block output is before in advance we are imposing complex conjugate, so that output of that block is becoming a real value. So to exploit these real transformation techniques, there are many other techniques, not only Hermitian symmetry. We have a discrete Hartley transform, discrete cosine transform, discrete sine transform, Hadamard coded modulation transform, wavelet packet division multiplexing. Like so many techniques are available in literature, so we can use them. So if you using a DHT based optical OFDM, so IDHT format is used, and correspondingly DHT format is used. So for DHT based optical OFDM is a format of kind cos plus sine. So cos, if you are using a inverse discrete Hartley transform IDHT, so the x of k goes through cos 2 pi n k by capital N, sin 2 pi n k by capital N. So this is equivalent to cas. We'll write it as a cas. That means cas means cos theta plus sin theta format. Now inverse discrete, after this inverse discrete transform, we'll bring it back to the DCT. So if you apply all mathematical information over here, so finally the signal becomes a real signal. Okay. So now in this work, we have also incorporated a DC bias OFDM and asymmetrically clipped OFDM. The asymmetrically clipped DC biased optical OFDM. If you remember earlier, we have to convert the signal first into a real format. After the real format, if it is passing through positive and negative axis, we have to bring entirely to the positive. So entirely to the positive means initially explained what is it entirely to the positive. So we have to add some bias, right? So we have to add some bias or make it to bipolar to unipolar. So this to make bipolar to unipolar, some DC bias is added. This is called DCO OFDM, DC bias optical OFDM format. As of now, are there any doubts? Just you can give your feedback in the chat box. Okay, so I'm not receiving any information. This is the problem with half online. And how many of you, at least those who are working in, have you had any experience in visible light communication? Can you give your response? Okay, no doubt. Okay, so Sauro, Akshata, they said they are not working in the system. But you can try with your students. A small MATLAB program can be developed on a DCOFTM as their project works. It's very easy to write a MATLAB code for DCOFTM and even ACOFTM, ADOFTM. Okay, so similar to your wireless communication channel estimation techniques, here also we can extend the same channel estimation techniques in optical OFDM. Optical OFDMs are employed with different transforms. Just now I said DCT, DCO, DHT, or IFFT, and also we have used the Hermitian symmetry transform, right? So here the same channel estimation techniques we can even further extend to optical OFDM. So here one of the example what we have taken is ACO OFDM, asymmetrically clipped optical OFDM. So that means the receive after IFFT pass through your Hermitian symmetry block. Let's take one example. Suppose if I am getting my signal as some kind of a signal, if I am sending like this, then suppose if you are added with the DC bias, then it will be shifted, right? So some 10 volts it is shifted. So because of this DC bias value is added to the system, there is some kind of a noise is also adding to your system, right? So to tackle these issues, even we can change the formats of the bipolar to unipolar, from unipolar to bipolar, uh, by clipping the information, by changing the scenarios, right? Asymmetrically clipped and symmetrically clipped, and so on and so forth. We can deploy into their systems and we can make more corrective system. So now one of the problem is the channel estimation in ACOFTM, asymmetrically clipped orthogonal frequency division multiplexing system. I think asymmetrically, I'll explain in some part, not mentioned here. So here what we have done, even using a fast Walsh-Hadamard transform is used in place of your IFFT block directly. Means earlier we have used Hermitian symmetry and IFFT block, right? So here Hermitian symmetry block followed by IFFT block. So in this case, without using Hermitian symmetry and IFFT block, FWHT block, fast Walsh-Hadamard transform coded system is added, and we have done some work on this. So too much of mathematics I don't want to explain. So just we concentrate on DCO-OFDM, which is very easy to understand. So what I said for DCO-OFDM, after Hermitian symmetry block and IFFT block, so after receiving a signal from IFFT block, to make this is in unipolar format, we have to make it in a bipolar format. So Uh, so this bipolar format, we have to make it into unipolar format. So we add some DC bias, right? So, but how much DC bias generally we have to add to the system is calculated based on the symbols what you are transmitting. That is expected value of x Cp of n whole square. The symbol energy we calculate and we multiply with some constant factor k, and based on that we compute the BDC. So that BDC is added to your IFFT output. Okay, so this BDC is represented in a log format, and this is in dB. Suppose if you take a unipolar signal to make this unipolar signal of DCO OFDM format is now becoming bias plus your original signal. So XCP of n plus BDC is added, right? So the received signal is now is having the received unipolar signal, your channel, and additive white Gaussian noise. Channel is H of n, Z of n is additive white Gaussian noise, X of n is your unipolar device, and R is the response of your photodiode. So here we have used R equal to 1, the photo response of your photodiode. So now when the signal is passed through the channel, we know it is a convolution format, the unipolar convolution format. And the channel format for a line of sight link is given in this, from the literature, it is given an LYS format of the channel is given in this multipath channel format. This is called Lambert mode M. Lambert mode M is used for representing a multipath channel model for visible light communication system. So because of the angle of the fall and power illumination, everything is taken into consideration. So now look at the diagram. One is a transmitter LED, one is a receiver LED. So if they are looking one to one, but because of the light emissions, so they fall on a surface and again they do receive the reflections at the receiver in different angles, similar to your multipath communications. So these propagation characteristics of the VLC also will add to make us to use the channel estimation techniques. Okay, so these channel estimation techniques, if you transform into the Fourier domain, I can easily write down my equations as yk as xk hk plus w of k or y in vector format, y equal to xh plus w. I can directly adopt the least square channel estimation. That means I have to minimize the error vector. So y minus hx is norm square is minimized. So then what is that h unless I have to fix in this format? So again we divide by h so that we'll receive the received signal will become the channel noise is eliminated. Right? So I'm not going to the full deep mathematics, and interpolation based channel matrix is also used. So now, suppose if you want to transmit the signal using an MPAM, like the combination of bits comes in, for each combination of the bits, the possible combinations, we just change the amplitude of the signal, right? So that is called PAM constellation diagram. So that is the format of a PAM. So this PAM, the received signal, is the amplitude, and your to make the signal to unipolar, bipolar to unipolar, we have to add a bias and additive white Gaussian noise. And also we have computed for this MPAM using the channel matrix of our visible light communication. Using this BDC, we formulated what is the probability of error for your MPAM system. MPAM for VLC, MPAM VLC modulation scheme. Okay. So we would see that the BER versus SNR in ACO-OFDM using MQAM as well. So as the QAM order is increasing, so my probability of error is going in a worse scenarios. So that means even at 10 SNR dB. The first one is ACO2 QAM is my probability of error, the first one. Then ACO 1024 QAM is the blue scenarios. Like that, I can see as SNR is increasing, my probability of error is happening with the QAM order at, at an higher SNR values. Similarly, is for ACO OFDM using MPSK is also computed. If you look at the MPSK, 2 PSK is giving at low SNR same BR, whereas 1024 PSK if you use, it is giving at higher SNR the same probability of error. So if you go on talking about the PAPR is also another problem in visible light communication. It is also used, it is also solved with the different techniques. So I'm not going deep into the mathematics. So we have conducted one more experiment where I can show you another experiment. This has become a journal paper in IEEE light wave communication. Sorry, light wave technology, Journal of Light Technology. So here what we have used, the format of modulation technique is changed. The format of the modulation techniques. DCO, OFDM we have used earlier, right? Now DCO, GFDM. DCO, GFDM. It is generalized frequency division multiplexing. And also we have seen the clipping distortion. So because if you know the diode clips your signals because it can transmit the signal only in this region, and otherwise if it is go beyond the version, it just clips the output. Okay. So if such kind of distortion, because when you are transmitting your signals using orthonormal carriers, so there is always a point that if I am using a more energy or if I am using a high voltage signal, so that may not be passed by your used diode. So some of the portions are clipped off. Some of the portions are clipped. So then how to tackle that issue? So that is a clipping distortion, double-sided clipping distortion. How to avoid this double, if the signal is clipped off, then how to avoid this these problems, and to how best you can decode your original signals into its original format. So generalized frequency division multiplexing, there is an OFDM scheme and there is a GFDM scheme, right? So GFDM and OFDM, the difference between GFDM and OFDM, it is orthogonal frequency division multiplexing. It is not a straightforward orthogonal division multiplexing. Only for every symbol we use a cyclic prefix for your OFDM, but whereas in GFDM, as a whole set, when I am transmitting the signal, at only one time, I'll use my cyclic prefix. That's the difference between OFDM and DFDM. So here also the same system. First we see the PAM DMT, discrete modulation technique. So use a Hermitian symmetry, IFFT, and the clipping. So we introduce some clipping intentionally. So then the same biasing is added and passed through your original communication channel. And we have used a equalizer and we have removed the imaginary part and given to the PAM demodulator. So math, I'm not going to talk much about the math. So different kinds of clipping noise statistics are taken. Lower for your diode, lower bottom clipping noise, and what is the format of that clipping noise, what is the CCDF function of that clipping noise. So those formats are taken into consideration and translated into a signal model. Then if that is also added to your system, if the clipping noise is also added to the system, what is your final probability of error is derived in math formula and also simulated this math formula. So just I want to show the outputs using a PAM DMT model. So one is theory, one is simulation. A 2 PAM is used. The blue color model is a 2 PAM and the red color model is a simulation. Both are matching. Okay. Similarly, if you take a BR performance of a PAM DMT in the another case, that is adding your AWGN, that is an ideal noise case. So both simulation model and theory model are matching 1 to 1. Now, so what is the CCD? Yeah. Any doubt? So now, so this performance and analysis under double-sided clipping and real-time implementation of this GFDM in VLC systems is analyzed. So totally we have written our own code for DCO GFDM modulator in LabVIEW, and every block is written in LabVIEW, and this change we brought to the LabVIEW, and also DCO GFDM demodulator is introduced. It's a new format for your original system. So that this is this one a QAM data is taken, and we also introduced a Hermitian symmetry system because we know either OFDM or a GFDM. The output of the block we have to use only IFFT block. So that IFFT output is resulting into complex format. So we have to remove the complex formats. To remove the complex formats, initially we use a Hermitian symmetry block. Then these Hermitian symmetry blocks are given with a modulator. So this is mod form of a modulator, MK symbols. So K symbols formats, they are transported into a single subcarrier 0, 1 and K minus 1 subcarriers. Then we make it into a real format. So similarly, we do it for the DCO FDM modulator. So just I'm not going through the most of the mathematics. Just see the diagram, what I'm going to explain in this model. So here, to test this DCO GFDM model, so we have used just expanding. What is the code we have written? So we have taken a data source. The data source is modulated onto a GFDM modulator. So this is also software block. So data source, DCO GFDM modulator, we have added a preamble and upsample and pulse shaping is done. Okay. So this all the blocks are implemented in LabVIEW software. Then, so this waveform is now given to ESRP. So this ESRP is X300. Okay. So the ESRP output, the transmitted waveform, see, we have used a blue wire. So ESRP output is connected with a bias T. Here you can see very clearly what is the bias T. So this bias T takes input. One is RF, okay, and another one is regulated power supply because diode need a regulated power supply. So RF and a bias. So this bias T takes two inputs, gives one output. So what it does, this bias T add your RF signal and a DC bias so that it makes RF plus DC. So this is given to an LED driver circuit. Okay. So and LEDs are also given with the DC power supply as a biasing. So LEDs are given with DC bias and as well as some DC bias is already added with your system to make everything is into the positive format. So this signal is passed through your LED driver circuit. So that means we are giving to LED circuit, LEDs. So here we have used an array of LEDs, 4 cross 4 LEDs. Earlier we have used only one LED. Now we have used 4 cross 4 LED. So now light is modulated. So look at the diagram of photodiode. So photodiode also need one power. So the power adapter. So that means we have taken from DCRPS, the signal is given to the power to the photodiode, and photodiode output is directly given to SRP N210. Okay, so from SRP N210 output we have taken. So again the same digital communication formats. So what we have done, so this output is given to your matched filter, because I know very well the matched filter is the best receiver under AWGN noise. And also we have used the synchronization and channel estimation techniques into this block. And we have removed the preamble because we have used a preamble at the transmitter. Then we have given that signal to a GFDM demodulator and the data sync. So this is experimentally tested in our laboratory. The whole system is experimentally tested in our laboratory. So how many carriers? We have tested for 64 carriers, and number of sub symbols in each carrier is 5. So the GFDM symbol in each packet makes into 4. That means also we have used some null carriers as 16, cyclic prefix as 8, preamble and 0 pad length as 128, pulse shaping is root raised cosine pulse is used with a length of 8, and our sampling factor for IQ sampling rate is 4 megahertz, and a modulation order is M equal to 4 in 16 quad. Okay. So what I am looking at, the performance comparison of a 4 QAM of DCO GFDM in different cases is studied. So we just see alpha with root raised cosine pulse and a Dirichlet DCO OFDM. So everyone is matching, the DCO OFDM is matching with your original communication signals. So these are the constellation diagrams for DCO OFDM. In phase component, in phase components for your DCO OFDM. As the order is increased, what are the constellation points? These are the screenshots taken from the receiver PC. And also the spectrum is also seen, the received spectrum and the transmitted spectrum. So the received spectrum is in blue and the transmitted spectrum is in pink color. So we will see some difference in the magnitudes of the received spectrum and the transmitted spectrum. In a smaller shot. So out of this work, we have published what I explained in GFDM scenarios, and also we have studied clipping noise for this system. We have published 3 papers. One paper is in NCC, one paper is in IEEE, that is Journal of Light Wave Technology, and one paper in IEEE Open Journal of Communication Society. All are SCA journals. 2 are SCA journals, and one is an NCC paper which is conducted by our IITs. So it has become a very good potential. It has given us very good impact of this system, and also we could see that this gives us very more weightage to our data. The later, what we have seen, can we use without any Hermitian symmetry, the signal can become a real signal. So just we have added some auxiliary symbol calculation before giving it to the IFFT block. Then with that format, so that means what we have seen, suppose a 1 symbol duration, we have certain points of original data and Hermitian symmetry data, right? So now we have entirely removed the Hermitian symmetry block. So in the 1 symbol duration, we have used our original data and auxiliary data. The arrangement is done such that the output will become always real. So those arrangements are given in this format, and we could publish a good work using the auxiliary data. So entirely we have removed the Hermitian symmetry block, and also here also we see transmitted packet is in the plot A. Transmitted packet is in the plot A, received packet in the plot B, and we are seeing a difference in the received signal, some delay. This is the delay we have to estimate first using a correlation. So I keep on see the received signal in windows, and the previous window, the first window, and the previous window, we make some correlation. So where suppose I am getting a maximum correlation, that means I am receiving the data. So from there we translate the signals, and there are different signal synchronization synchronization techniques also deployed into this. So for a PAM DMT optical wireless communication, using separation samples of those signals, we have used the setup. So now the next work what we have done in this visible light communication is using machine learning techniques. So the work is on progress. For the channel estimation, we have used a machine learning, and your data formats also we have used the machine learning techniques, and that work is under progress. And one more work what we are doing at Native Warang in my group is RIS based work. So let me check the RIS. Just wait a minute. Okay. Ravi Kumar is asking me what is a transmitter and receiver separation. Are you asking for VLC or are you asking for GFDM? Ravi Kumar, are you there? So the GFDM format. So even this GFDM we have tested using wireless communication using two antennas, the transmitter antenna and receiver antenna. So we could separate the transmitter antenna and receiver antenna because our lab dimension is very small. It is up to 11 meters from one end to the other end. So for GFDM case, it is perfectly fine. But for VLC, what I said is only we have tested only for 10 meters. So the problem with VLC is our photodiode capturing capacity. So if you have a more space of your receiving the light falls on the surface of your photodiode, we can capture more amount of signal from the wireless communication. But our photodiode has a very less space. So we have ordered a new photodiode is yet to arrive. But only the problem is custom clearance. So our institute is taking care of that custom clearance. Once it is done, then maybe it is already order is placed. Okay. So next we are integrating with IRS, Intelligent Reflecting Surfaces. So just I'll give you the overview of these intelligent reflecting surfaces working principle. So this is actually the downloaded PPT, not of my own PPT. So this any conventional base station if you take, you see some users are unlucky users, right? So these okay. मैंने जा रही जाओगे हाँ मम्मा आपको जाओगे ठीक है पापा आपको ड्रॉप कर दूंगा. Hello, somebody is asking one question.
No, ma'am, by mistake, I think someone put their mic on. That's why.
Okay. So So if you look at this diagram, if there are big buildings, some large vegetations, tall vegetations, so which stops your signal to go inside the unlucky users who are behind these buildings, right? So in that case, how to improve the coverage is the next question, right? So the fading, how can we give good access to these unlucky users? So the question comes, lucky users anyway, they are in front of, they could see the base station and they are receiving a 40 times stronger signal. But unlucky users, even if you increase the antenna gain, there is no benefit from the antenna gain as well. So in such times, is there any way out to use service to the unlucky users? Yes, this can be done using your beam forming by, you know the principles of the beam forming, a constructive interference and a constructive uh, way of adding the signals together. So if you place one antenna beam and if you place a two antennas of the same angle, so at one point we would see that the black line which is showing is constructively adding the signals, right? Similarly, in the second diagram, if I am placing two antennas, the same signal but with a different delays, then the constructive interference is added at different angles. So we would see the added signal value. So like that, if you make antennas with different delays and different gains, and there is a possibility that I can increase my beam length. So here in 4 cross signal gain, we increase the beam length to a larger distance. So why can't we use one reflecting surface where the signal falls on the surface and they will be directed towards the faded areas? That is the concept of intelligent reflecting surfaces. So first of all, we have to make these intelligent reflecting surfaces. It is like a antenna array, but this antenna array is controlled by some software which makes your format of the signals to form a beam in different directions. Okay. So till now people are doing antenna alone and there is no control for the antenna. But can we make the antenna and the control together in one system? So just we leave that system on top of the wall as a passive element where we'll place that on top of the wall so that it receives the signals and makes a beam forming and it controls the signals towards the intended user. That's the concept of intelligent reflecting surfaces. So these intelligent reflecting surfaces, if you look at this diagram, so this diagram makes one extra path which is coming through inside to your building through your inside to your buildings through your windows, right? But at that window point, the user is penetrated by the wall, so he is unable to receive the signal. But there is a solution. So what is that solution? If you keep where the signal is coming through the window, at that place, if you place an IRS, then IRS makes the signals to transmit even further larger distances. So that is the concept he has used, reconfigurable intelligent surface RIS. Okay. So because of this RIS, he could able to receive the signals with more SNR. So where this one we are currently working on this problem, reconfigurable intelligent surfaces, and another one is visible light communication with machine learning algorithms, and the design of this array uh, surface, and also the programmable controller using your Arduino or FPGA, and one passive path. So we have to, for each element of the array is attached with one switch. That means one diode switch. So keep on and off. So how many diodes are on such that it makes beam into one direction. So we have to make some optimization, right? So where we can use our machine learning algorithms so that the signal passes through the intended users, through the faded areas. This is where the systems and the math and all, I'm not going to take much time. So we are currently working on this problem. And so you can find my Google Scholar citation. So the first one is Venkatamani Vakamulla is my Google Scholar citation. You can see some of the papers which we have published in recent years. So first we start with some mathematical work, and then later we try to implement that math into the SDR platform, and we test in real time. So we could publish good amount of work into the moderate journals and even IEEE journals. So this work is controlled wireless channel using multi-antenna, multi-IRS assisted communication system, a comprehensive performance analysis. This is IEEE Latin America transaction. And next one is, I said, a low complex and power efficient optical OFDM for VLC systems. And this is a real-time work. The second paper is a real-time work. And in IRS, KMU fading is a math work, and low complex OFDM based TCO OTFS modulation for VLC systems is physical communication, and like that, so many good number of publications are there. So those who are interested, maybe you can go through our some of the papers. And also we have written one book in for VLC using MATLAB. Maybe I can show the book. Oh, yes. A visible light communication, comprehensive theory and applications with MATLAB. So we can find some MATLAB programs to start your visible light communication. So even you can refer to your students to use this book to get some idea how to start coding for your visible light communication modulation schemes and channel estimation. Some of the techniques, transform techniques, are also given in this textbook. So they can go through this textbook as well. So with this, I hope people could see what kind of a work we are doing at NIT Warangal, and also there are many opportunities at NIT Warangal. So people who wanted to do their research in full time and part time. So for full time, they should have a GATE qualification. For part time, no GATE qualification, only experience is sufficient. So they can register with us. But everything is based on, there is a test, there is a written and interview. So if you pass the written exam and the interview, yes, you are good at your research. Definitely, NIT Warangal is offering PhD program, part-time and full-time, and even summer internship to the students. And also you can learn more things. We can access our labs. So many opportunities are available. So with this, I am closing my session. And are there any doubts? The forum is open for question and answers.
Thank you, ma'am. So
Yeah.
participants, if you are having any questions, either you can put in chat box or you can simply unmute yourself and ask your question.
There are no doubts.
I think there are no doubts. So
Yeah.
thank you, ma'am, for this wonderful session.
Uh,
So
One
I
is
think there
asking
is
one.
something.
Yeah, yeah.
Yeah.
Brief about MIMO in VLC. Yes. So MIMO in VLC, yes, we can do. You want to do in experimental, in theoretical, many things we can make, and experimental also we can make, because ESRPs can give support up to 4 cross 4. So 4 cross 4 by more. Also we can make, the possibility is there in experimental basis. But theoretical, any formulas only, write the formulas, right? That is also possible. MIMO in VLC is possible. And anyway, before going to the MIMO, it is visible light communication is basically used for short distance communication. So we may not use MIMO because unnecessarily we are putting more burden on the communication system. That is also we have to see into the experimental aspect.
Yes, please. Any other questions?
So now today is how many days passed?
This is last session, ma'am.
Okay. Only in the morning session you are conducting and evening sessions conducting, right?
Evening session, ma'am, 6 to 9.
6 to 9.
Majority of the session are from 6 to 9. Today we are having from 2 o'clock to 6:30.
Okay. Who is the previous speaker?
There is a speaker from industry, from cloud computing.
Okay.
Uh,
Okay.
so thank you, ma'am. Thank you for sparing your valuable time for us. And hope our participant will definitely get benefited what you have shared with us. Thank you very much.
Thank you. Thank you so much.
So, dear participants, now we are going to share the quiz assessment link to you by using chat box, as well as I will share that link in WhatsApp. So please simply attempt that quiz. It is for half an hour, and then after you will get a feedback link. You need to share your feedback. After that, we will simply again join the session at 7:30 for valedictory. So simply I'm going to share the feedback and quiz link in WhatsApp as well as in this chat box. If you are having any confusion or doubt, then you can put your query in chat box, or you can simply put your query on WhatsApp. So participant, I have shared the link in your WhatsApp group as well as in your Teams chat box. Now you can attempt the quiz. It is open for all.
Good evening, everyone. Very soon we will start with our valedictory session.
देखिए सो अच्छा रो रहा होता वो
कौन?
रो रहा होता काना काना रो रहा होता काश अगर हम उसको असली में बोलते कि हम घर जा रहे हैं तो वो खुश हो जाए
Soumya ma'am, please proceed.
Good evening, sir. Yes, sir.
Good evening.
So, dear participants, a very good evening. You people can turn on your cameras and keeping your mic muted. You can please turn on your cameras, everyone. We want it like an open session to share our experiences. Yes, everyone, please turn on your cameras. Hopefully, you have enjoyed the entire week of learning. It was so informative. So let's have a open discussion because it will officially will mark the valedictory session or valedictory ceremony of the FDP. So please be a spot. Just turn on your cameras and let's have a open discussion. Okay. So as I started with the welcome and inauguration part of the FDP, so I'm very honored to address you all as we are about to conclude the 1 week faculty development program on AI enabled collaborative learning in 60 and beyond. So over the past 1 week, we have explored that how artificial intelligence can be used in collaborative learning in context of 60. So I am totally overwhelmed with all 13 sessions and the informative and worthy talks delivered by industrialists and educationalists and such a high profile researchers. So I'm personally overwhelmed and this platform is open for you all to share how you felt, what you learned, and if you want to give any suggestion for the improvement, or if you want that we should conduct such FDPs in further way or the version 2, 3. So just you can give the feedback. And we are supposed to record the experiences, live experiences, and maybe we will use some clips on the social media to share the glimpse of the event. So it is my humble request to turn on your cameras and make it a successful valedictory session. Yes, ma'am. Dr. Sunita Soni, ma'am, with us. G. Nagarajan, sir, is with us. Yes. Yes, please, everyone, just don't feel hesitation. Just turn on your cameras and let's share that how we felt. Because I have beginning of every how I'm feeling. I so interacted with each and every speaker. So please turn on your cameras. So Sunita ma'am, how did you feel about it? आपको कैसा लगा पूरा 1 week का experience? हमारे 13 sessions थे. Please turn on your camera so that we can have at least a picture, a group picture for all the participants. Yes, please turn on your cameras. Let's have one group picture.
It was very nice session, ma'am. So informative also. Thanks all the team of the FDP.
Thank you, sir. Thank you, Rupak, sir. So would you like to share some specific points? Like there were 13 sessions. Every session was different. Sanjay sir did hands-on also, a personal assessment also. So you feel free. Means we all are educators, we all are professors. We understand कि कुछ flaws भी होते हैं, कुछ हमें अलग भी मिलता है. तो please share जो भी आपको लगा. It's open platform.
Session was so informative. सारा सेशन अच्छा था. मैंने लगभग देखा सभी. सारा सेशन में कुछ न कुछ गेन ही किया. We all just
That's great. That's great.
हम चाहेंगे ऐसा FDP again फिर से हो. It was so nice and very good. Thank you, ma'am.
Very nice, sir. Very nice that you showed active participation, because we all understand that out of the hectic schedule of over 9 to 6 and after 6 joining such FDPs, but it is to just sharpen our skills, to boost our confidence and learning. So thank you so very much, sir, that you share your experience. Please, rest of the participant, at least turn on your camera so that organizers can take a snapshot of the group. And it's an open platform. You can share your responses, your feedback that you have filled in the form. That is okay. That formally we have recorded your responses and feedback. But we will appreciate अगर आप लोग यहाँ share करेंगे अपनी जो भी आप कहना चाहते हैं.
This is Nagarajan, myself.
जी
My
जी
voice
sir.
is audible? Yeah.
Yes sir, you are
I
clearly
am
audible.
from Tamil Nadu, actually. I sincerely thank the organizer
That's
of
great.
FTP on that concept is very nice. I mean, AI enabled collaborate learning in 6G and beyond. It's a unique this project and this title also unique thing for an insightful and enhancing experience. The sections were well structured. First of all, this structure, this essence is overall a well structured, offering deep insighting into AI role in 6G technologies and and collaborative learning also. This is the thing. And this sourceful persons. Moreover, 13 sections are completed. I think so, right? Um, The sourcing persons are complex and topics are very easy to understand also. And the overall discussions also very highly engaging with the practical examples also. I will ask on questions. I mean, I will raise one question means suddenly we will give the solution, the further oriented ideas also. We'll give the further oriented ideas also. Overall, this FTB has a I mean, understanding and inspired incorporating these concepts also. I mean, it's very useful for my teachings also, teachings and the results also. So overall, it's nice. Thank you for the excellent learning opportunity. Thank you, and
Thank
special
you
thank
so
you
much,
for
sir. Thank you so much.
Soumya boy, Soumya. So
Yeah, this
special
is Dr.
that,
Soumya Goyal.
yeah,
Right.
right. You are a special person in this overall thing. Really, thank you.
Thank you, sir. Thank you.
Thank you.
Thank you for your active participation, because sometimes our audience were there, but they're only in the
Mm,
list. They didn't respond. Then you were the only
mm,
one who asked for the questions. When some of the
mm,
speakers asked, raise some question, raise some question. Are you listening to me? And you saved us, because we, to
mm,
invite any speaker to be a
mm,
part of our
mm,
FDP, they spare their
mm,
time, they share their
mm,
knowledge, and sometimes
mm,
participants are there, but they are not
mm,
actively involved. So you saved the situation. Thank you so very much, sir.
yeah, thank you. Pleasure's mine.
Thank you. Thank you, sir.
Thank you.
So next, who is going to share? Please turn on your camera and please start sharing.
Uh, Good evening, Soumya, Dr. Soumya.
Yes, good evening, ma'am. Good
Uh,
evening.
I'm Dr. Jayanti from RV College of Engineering, Bangalore, Karnataka.
That's great. Nice to hear from you, ma'am. So let's know, how did you feel? What did you learn? How was your experience?
Yeah. Madam, that 5 days FTP, it is on my own interest I took because I saw the topic, it is 6G beyond with AML and all. So, my research area is in 5G and I'm looking for quantum communication for 6G, how we are going to implement quantum communication or quantum security for 6G networks. And to support these, my trust areas or my research areas, few sessions were very good, madam. They gave in-depth knowledge, and speakers gave some research areas for the further work. Especially, all the sessions were very good, but Mr. Sujay Kumar from Telco. So, because they were very much connected to my topic, because I'm into 4G, 5G. Sir gave how to enable or implement the AI concepts into the 6G so that all the parameters like data rate, latency, and other things will improve. Okay, that was very nice topic. And further, what I mean, sir gave one hands-on also. But what we were expecting, my expectation at least, okay, online hands-on would have been better. At least one simple program with a particular tool, okay, for 6G, 5G, where how we can implement that AI into this particular topic. Sir had nice GitHub tools. Okay, with that sharing that GitHub tools and just making us to work with that GitHub tool, that would have been better actually. And other session really it was good, madam. Today's sessions were also, Mani madam, that was very nice. All the sessions were excellent. Okay, so I'm just pointing few actually. So thanks you
That's
for the
great, ma'am.
organization. Thank you for the organization. I would like to thank Atal Port also for this wonderful opportunity. So you were very interactive, both of you, Soumya and Lal Pratap. So for each and every sessions, they were very interactive, madam. And also one more thing, Papa, for each and every query, all the speakers were giving the query. I mean the answers
Yes,
for that.
ma'am.
Uh, so
Yes, we
we
are very grateful to them that they spared the time and they addressed the queries of each and every participant. And
correct.
even they shared their contact email IDs.
Yes, madam.
Some
We
shared
already.
personal and some shared official.
Yeah,
Yes, ma'am.
LinkedIn contacts also they gave. We are already following
Yes,
few
ma'am.
speakers, so we are talking to with them personally also. They are giving. It was very nice, madam. Actually, it gave more connections, networking. So such type of thing should be there where our network will increase.
Yes, Yes, ma'am.
Thank you so much,
Thank you so
madam.
very much. Thank you so very
Thank you.
much.
Thank you. Yeah.
Thank you, ma'am. Thank you so much.
Right. Yeah.
Yes, please. Next, who is going to share his or her experience? You people are most welcome to share how was experience of 1 week adopted and they accepted our invitation for this FDP. So please turn on your mics, unmute it, and share your feedback. You people are most welcome. And it will help us organizers because what happens now, if you will share your feedback, we will learn something, we will improve our next events, and it always motivates the organizers. So please share your experiences or feedbacks. Dr. Atul, would you like to share your experience? Just how did you feel? What did you learn? Yes, please.
Good evening, everyone. Am I audible?
Very, very good evening, sir. Very good evening.
First, I would like to thank to all the organizers for this FDP. And I am from computer science background, so the telecom technologies were just new for me. So I have learned a very much, and I can say I could understand and learn the things which I did not know, because that was not uh, much related to my field. And I personally enjoyed this session that was on the deep learning, relevance of deep learning with the telecom communication. And I enjoyed that session also. And the timing, I would say, of the FDP was very good, because if the time of FDP is in the during the working hours, then we have some other duties and we be in the meeting, but we cannot listen
Exactly,
everything.
exactly.
Yeah. So the timing was
Right,
perfect,
right,
ma'am.
right.
That's why we could attend everything. We can listen everything, and the sessions were very informative. And the organization, the conduct of whole FDP was excellent. I would appreciate that Lal sir and you
Thank you so much, sir.
managed very well, and it was a great experience. And hopefully I look forward to have more such FDPs from you.
Thank you so much, sir. Thank you so very much.
Yeah,
So
thank you everyone.
it's really very nice to have all the participants here, and you people shared your feedback, your experience, what you have learned. You reflected upon that. We highly appreciate. Now, I would like to request Dr. Arvind Thaka, the coordinator of this FDP, to give a vote of thanks, and then we
So,
will close the
madam,
FDP successfully. Ji, sir.
am I audible?
Yes, sir, you are audible. If
Okay.
possible, can you please turn on your camera also?
1 second, 1 second.
Ji, sir.
I think my
Camera is on now. You are visible, sir.
Acha,
Okay.
I think okay, okay. It was not visible to
Okay,
me.
please.
Now sir, I have changed some screens. Sorry.
Okay. Okay, ma'am. Okay, it's okay. So,
Ji, sir, now I
dear
can see you.
participants,
And it's really nice if everyone turns on the camera. Yes, sir. Yes, sir.
okay, so dear participants, esteemed faculty members, honored guests, and expert, it is my pleasure to stand before you today for the valedictory ceremony of the 6-day FDP on AI-enabled collaborative learning in 6G and beyond. So I would like to express my heartfelt gratitude to ATAL Academy for sponsoring this FDP, which has brought together the esteemed faculty members from across the country to explore the extinct realm of AI-enabled collaborative learning in 6G and beyond. I express my sincere appreciation to MUJ leadership for their support and encouragement to empowering faculty members, which is truly commendable. So over the past 6 days, we had the privilege to engaging with renowned experts in the field who have shared their insight and expertise on the latest advertisement in 6G, AI, and collaborative learning. So through this FDP, we have not only gained the knowledge, but also forge a new connection and collaboration with fellow faculty members. So as we conclude this FDP, I would like to emphasize the significance of AI-enabled collaborative learning in the context of 6G and beyond. The next generation of wireless communication system will require pioneering the level of collaboration, coordination, and intelligence. So in conclusion, I would like to thank you, each one of you, with your active participation and engagement throughout the FDP. I would like to express my gratitude to our expert speakers and fellow colleagues without whom this program would not have been possible. So let's continue to collaborate, innovative, and push the boundaries of what is possible in AI-enabled learning in 6G and beyond. So thank you so much. So in future, we will also conduct this type of FDP. Okay, thank you guys.
Okay, sir. Thank you so much. Dr. Lal Pratap Verma. Sir, please.
Okay, thank you. Thank you
I think
everyone
you should
for actively.
Yes, sir.
Okay, so thank you
So
everyone.
if
Good night.
anybody wants to share anything, yes. Okay. Thank. Bye bye. Take care, everyone.
Okay, bye.
Thank you. Thank you, ma'am.
Thank you.
Bye bye. Take care.
Thank you.
Thank you, ma'am. Thank you, sir.